Hello and welcome to Organic Chemistry Lesson 7. Now we're going to start thinking about carbonyl compounds. Now first you need to know what is a carbonyl group. A carbon atom joined to an oxygen atom with a double bond. So if you see a carbon bonded to an oxygen with a double bond, you know carbonyl. Now you have the first two types of carbonyl compounds, which is aldehydes and ketones. An aldehyde is where the CH moiety is at the end of the carbon chain. Ketones is where the C oxygen double bond carbonyl group is in the middle of the carbon chain. The general formula is CnH2nO. Now very important, here is a general carbonyl compound, meaning it's got a carbon-oxygen double bond. An aldehyde is where the carbon double bond oxygen is at the end of the chain. That means there should be a hydrogen. Here the carbon chain can continue, but the hydrogen tells us it is at the end of the chain. And a ketone, where you have the carbon double bond oxygen, but it is in the middle of the chain. That means this carbonyl carbon should be bonded to two carbons, one on either side. Aldehydes. Aldehydes are used in resins and they are produced at 6 million tons per year. Also in perfumes and flavorants. Here's an example. This is butanol because it's got 1, 2, 3, 4 carbons. The structural formula. Then you have the condensed structural formula. We have a CH3, CH2, CH2, and then a CHO, which is the clue for you to know that this is an aldehyde. You need to look for the CHO. And then the molecular formula is C4H8O. Ketones. Ketones are used as solvents and for the production of polymers and pharmaceuticals. This is acetone, which is in your nail polish remover. Acetone's got 3 carbons and there you have your carbonyl group in the middle of the chain. So this is the structural formula, here's your condensed structural formula, and here your clue for a ketone is the CO part in the middle of the chain. And then your molecular formula is just C3H6O. IUPAC names for aldehydes. The aldehyde suffix is -ol. That means at the end of the chain you will have the -ol part. You have the base name and the alkyl groups as usual. Example 1. Give the IUPAC name of this molecule. The first step is always to identify your functional group. So if you see this part, a carbonyl group with a hydrogen bonded to it, you know this is an aldehyde because it's got a carbon-oxygen double bond at the end of the chain. Then you find your longest carbon chain and you number your carbons. Your carbonyl carbon will always be number 1. So 1, 2, 3. And then you know it is propanol because prop for 3 carbons, on for only single bonds, 1 for ol. The ol is at carbon 1. But since the carbonyl carbon will always be at number 1, it is alright to omit the 1 but only for aldehydes. Example 2. Draw the structural and condensed structural formula for 3-methyl pentanol. Now the first thing you do is you draw your 5 carbons. 5 carbons because of the pent part. Now you put your substituents on. 3-methyl, so at carbon 3 you have a methyl, and now at the end of your name you see ol. Therefore you know there should be an aldehyde group and it should be at carbon 1 always. So carbon 1 should now have a double bond to an oxygen and a single bond to a hydrogen. And then your condensed structural formula have the CHO aldehyde clue in the beginning. Then you have a CH2, a carbon which is bonded to another CH3, and then a CH2, CH3 which is there. Example 3. Give the IUPAC name of that molecule. The first thing you do is draw your structural formula. There you go. Here is your CHO. CHO means aldehyde. Aldehyde means carbon, double bond, oxygen and a hydrogen. There is your CH2. Then you have a carbon with a hydrogen and bonded to a CH2, CH3. And another CH2, CH3. First step, identify functional group. There you see, aldehyde. Longest carbon chain. Let's count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, remember, your aldehyde carbon, your carbon is always number 1. And now if you look at, say, your substituents for the purple numbers, the ethyl substituent is at carbon 3. And for the green one, it is also at carbon 3. So both sets of numbers are correct. Then you notice that there is an ethyl substituent, and then your name would be 3-ethyl pent on, because there's only single bonds, and then ol to indicate the aldehyde part. Now for ketones. Ketones have the suffix -one at the end of the name. And then the base name and the alkyl groups works as usual. So example 1. Give the IUPAC name of this molecule. First thing is to identify the functional group. If you see a carbon double bond oxygen, you know it should either be an aldehyde or a ketone. This is a ketone. Why? Because it's bonded to 2 other carbons, one on either side. That means that this carbonyl group is in the middle of the chain, and that makes this molecule a ketone. Next thing, number your carbons. If you number from the left-hand side, you have the purple numbers. If you number from the right-hand side, you have the green numbers. So for the purple numbers, you have the carbonyl carbon at carbon 2. But for the green ones, the carbonyl carbon is at carbon 4. Now remember, your functional group should always be at the lowest possible carbon number, which is 2 in this case. And therefore the purple numbers are the correct ones. So then the name. Pent, because there's 5 carbons. On, because there's only single bonds. 2-one, to indicate that the carbonyl part is at carbon 2. And -one, to indicate that it's a ketone. Example 2. Draw the structural and condensed structural formula for 4-methyl pentan 2-one. First thing, you draw your 5 carbons. Why 5? Because it's pent. Then you add your substituents. 4-methyl. So at carbon 4, there's a methyl group. Then 2-one. That means at carbon 2, you need a carbonyl group, which means it's a carbon with a double bond to an oxygen. And there you go. Then for the condensed structural formula, you have your CH3 there, then your CO, then you have a CH2, which is there, a CH bonded to a CH3 and another CH3, therefore CH3 with a 2 in brackets. Example 3. Give the IUPAC name of this molecule. Now you should see red lights and note that you need to draw the structural formula. So CH3, there it is, CH3. Then the CO, which is your clue to know that this is a ketone. So there's your CO. Next you have a CH2, and then you have a carbon with two CH3s. CH3, CH3, and then CH2, CH3, CH2, CH3. So now for the name. The first step is to identify the functional group. You see a carbonyl group, and it's in the middle of the chain because it's between two carbons. Therefore, you know this is a ketone. Next step, find the longest carbon chain and number the carbons. So if you use the green numbers or the purple numbers. For the green numbers, you have your carbonyl group at carbon 2. For the purple numbers, you have the carbonyl carbon at carbon 5. Therefore, if your functional group is at the lowest possible carbon number, it's the correct one. Therefore, the green numbers are correct and the purple numbers wrong. Now you look at your substituents. You have a methyl at carbon 4 and another methyl at carbon 4. Therefore, your name should be 4,4 dimethyl. Hex because there's 6 carbons, on because there's only single bonds, 2 to indicate the carbonyl carbon, one to indicate that it's a ketone.